All right, we continue the lecture on Power System 1 EEC 122. Today we are starting with gas turbine power plant. This is a generating station that employs gas turbine as the prime mover for the generation of electricity energy. In a gas turbine plant, air is used as the working fluid. Air is used. You see the diagram here. Look at the diagram. Let me minimize it. Air is used in this gas turbine. There is air combustion chamber where the air is heated up. When the air is heated up, it produces pressure. Initially, the air will have been put under pressure, compressed. Then when heat is supplied, the pressure will increase. The pressure will be forced out. When it is forced out, the force is used to roll a turbine, gas turbine. Just like you have a windmill. The air is the one that makes the windmill to turn. But this one is a turbine. The air that was pressurized and then heated up will jet out with full force to turn the blades of the gas turbine. The gas turbine is actually connected to the generator. The generator, yes. Then electricity is generated. There are some advantages. It is simple in design compared to steam power station. The gas power station is simple. Number 2, it is smaller in size. Number 3, the initial and operating costs are much lower than what we can talk about in steam power station. Number 4, it requires comparatively less water as there is no need to condense any steam. There's no steam. So even if it uses water, maybe for cooling, there's nothing to condense. So it does not depend on so much water. Number 6, the maintenance charges are quite small. The maintenance charge is small. The next one, gas turbine are much smaller, simpler in construction and in operation. They are simpler in construction and operation. Next, it can be started quickly from cold condition. Yes, the moment you compress it, you fire it up, you see the result. The last one, there is no standby losses like you have in steam turbine, steam power plant. You have to wait for the water to boil. Meanwhile, the heat is going, fuel is running out, yet you have not even got the steam that you need to force out, to jet out and to push. So we have some advantages talking about gas turbine, but nevertheless there are some few disadvantages. Number 1, there is problem of starting the unit, because the starting turbine, the compressor has to be operated for which power is required from external source. That means to compress the air, you need external source. So you have to, maybe you bring in electricity somewhere to compress it. So after some time, it will generate power by itself and you don't need external force. But initially, you need external power. Secondly, the overall efficiency of such plants has about 20%. It is low. The efficiency is low. Yes, because maybe you heat up the air, it jets out actually, but when you compare the amount of heat, money you spend on heat, you may not get it out in the amount of electricity you generate. So the efficiency is 20%. Too low. Too low. Then finally, disadvantage is that the temperature of combustion chamber is quite high. For you to heat up the air, you need a lot of temperature. It's so high. Those are the disadvantages. Look at the main components in gas power plant: the compressor, the regenerator, the combustion chamber, the gas turbine, the alternator or the generator itself, then the starting motor. So that's it. Regenerator or pre-generator. Alright, we move to the next topic: wind power plant. Wind power plant. As you can see from the diagram, wind energy is converted to motion, then to electricity. This method can be used where wind flow for a considerable length of time. Here you need a lot of wind. I need the wind to blow for a long time. Wind energy is used to run windmill continuously. You can see in the figure above. The generator is arranged to charge batteries. So the batteries in turn will be used to power some loads when the wind stops. The method has advantages that maintenance and generation costs negligible. The moment you install it and you have wind to blow it, you don't need so much to maintain it. Yes, you don't need so much to maintain it. However, there are some disadvantages. Number one, variable output. The output is not constant. It will be rising and falling in magnitude because the wind may blow easily, gently, or violently. So when it's blowing violently, you get a lot of power generated, but when it's not blowing too much, the power will reduce. Secondly, it's unreliable because of uncertainty about wind pressure. It's unreliable. You cannot predict that this is the amount of energy you're going to get from windmill, because you cannot predict when you have enough pressure. Number three, disadvantage: power generated is quite small. Yes, the efficiency can be said to be low because you get little power from it. Even though the wind is turbulent, it may not be enough to generate enough power. The next one is solar energy power plants. Solar energy power plants. This one gets its primary source from the sun. The sun shines and the sun has heat energy radiating from it. The energy is trapped through the use of photovoltaic cells. Then the energy is converted to DC current power, and that can be further converted to AC. So what you see from solar panel is actually DC. The solar panel is like a converter converting solar energy from the sun to electrical energy. The electrical energy is in DC form, although you can convert it to AC. Depends on the kind of output, the nature of the output you are looking for. Okay, there are many applications. You can use it to pump water for irrigation. You can use it to power your lighting in the house or in the streets for street lights. Can be used also for refrigeration of vaccines. Let's go on. Let's see the basic components of solar energy power plant. Number 1, the solar panel, photovoltaic cells. Number 2, storage facilities like batteries. Number 3, charger controller. This one controls the charging system. Number 4, the inverter. The inverter is the one that converts the DC to AC. Like I said, the solar panel will give you DC. So if you need AC, you bring in an inverter. Then lastly, you have the load. The block diagram is shown here. Solar cell array. Then you have the DC being produced, which you can convert to AC, whichever one. Then it goes to control unit to set the controller, to set the charging parameters. Then you have power distribution, you have loads. Okay, we see battery for storage here. The battery storage will actually have a charge controller. It's part of the control unit. Control unit is generally for all the controls, but the one that controls the charging of the battery is called charge controller. We go ahead. Let's see the types of solar systems. There are various types of photovoltaic systems configuration used for different applications. It can be used as standalone. A solar system standalone, like you have your generator in the house, standalone. It can be integrated, maybe in a solar car. It's integrated inside the car. Then we have grid connected mode. This one is like a solar farm, and the solar system is connected to the grid, transmitted nationwide. Now you can decide to use your electricity directly without battery. The solar cell is connected to the load, but that load has to be DC load. Or if it is AC load, you bring in an inverter so that you enjoy AC at the end of the terminal. Without battery, as the sun shines, you consume the converted electricity. But the thing is, at night, when there is no more sun, you cannot use it because you have not stored any power. That's how it is. Okay, let's go on. The next subtopic is solar energy. The sun gives us the solar energy. The sun produces light energy and produces heat energy. That is solar energy. You see, rays can be used. The sun rays can be used for a number of advantages. The solar energy is very versatile and has limitless potential in transforming our lives. Studies have shown that we are endowed with the availability of this kind of energy. Nigeria receives a lot, and about 5.8 times 10 raised to power 6 megawatt hour of electricity energy can be obtained from the solar energy. So if you use the whole of Nigeria to generate energy, that energy should be able to power the whole world. Yes, it should be able to power the whole world. There is enough in solar energy. Now, solar energy technology can be divided into two. Number one, solar thermal, and number two, solar photovoltaic. For solar power and thermal, the heat energy is trapped. It can be trapped maybe using a lens. The light coming from the sun can be used. The heat coming from the sun combined together to boil water. When this water boils, the steam can be used to drive a steam turbine. So that's the solar thermal. The heat energy can be used to heat up a system, but the light energy from the sun can be converted to heat energy by using lens. A convex lens is brought to converge the rays of the beams of light, concentrate it at some point, then heat is highly generated. In fact, this one gives you more heat than the heat coming from the sun. The conversion from the light alone can give you super heat. This is used in some countries to heat up some liquid. This liquid is used to drive, the heat from the liquid is used to drive turbines, and power is generated. So the second one is solar photovoltaic. This one employs the use of solar cells to trap the energy from the sun, light. This one is just light. When we're talking about photovoltaic, is light. The heat energy is even a disadvantage for solar cells. Had it been it is possible to get only the light from the sun, it is enough. That is what photovoltaic is looking for. So the light is converted to electricity. The photovoltaic cells can be meshed together to form solar module, and you can keep on expanding it until you have a mega electricity generation from solar cells. The solar cells are very light and easily installed. It requires small amount of maintenance. I have a solar panel I kept on the roof. It charges. I don't need to go there to do anything. It's just there on the roof. When the sun comes, it begins to charge the battery. When the sun goes, it stops. I don't need to go there to do anything. I don't need to see the panel. So the maintenance is cheap. The modules produce DC electricity. You can use that DC electricity directly or store it in the battery. You can use it to power your fan directly in the day, power other things. But if you want to use electricity in the night, you need to store some in the battery. So the modules have been used for the following. Number one, to pump water. Number two, to refrigerate and preserve vaccines. Like we have the medical centers around us here in Akwa Ibom State. We have centers everywhere. If you check them, you see solar panels on their roofs. And you see that they don't have electricity most times from the national grid. They pump water with those solar panels. Then they connect another set of solar panels to their fridge, solar DC fridges, to freeze, to refrigerate drugs, vaccines. That's why you see they give children immunization a lot when you talk about the medical centers, primary medical centers. Lastly, we are talking about solar cell power generating unit. For power generation, the system consists of arrays which are made up of photovoltaic devices. The inverter that is used to convert DC to AC. Then the battery to store the energy during the day. Then the controller unit to manage the automatic operation of the system. Like when we say for example, to charge the battery. You want to charge battery without destroying the battery. There must be a control so that when the battery is fully charged, you don't supply power again to the battery. It will spoil the battery. So the controller will look at it. Oh, the battery is fully charged. It will stop charging it. The controller will look at it. The battery has been used too much. It will cut it off so that it will not be used to zero. Using a battery to zero will also destroy the battery. There are some other controls in this system. Yes. For example, you want to charge a battery and switch to another battery. You want to do something like that. You want to switch from one panel to the other. You want to regulate some other things. You want to control. You can do that through the control units. One of the main solar photovoltaic electricity generation is one of the main challenge here is the high cost of the solar panel. High cost of the solar panel. The cost of the module, photovoltaic modules, they are very costly. A 12-volt module used to cost 30,000 naira. 30,000 naira. That was 2018, I think. But now we are talking 2023. With the new exchange rate, it is now more than that. The last time I was to pick up a solar panel, it was 100,000. Previously it was 50,000. Then going back again 100,000. I don't know how much it will cost now. So that is a major disadvantage of the solar power generating system. But at long run, a wise consumer will get back, break even, and even profit from it. Yes, because when you install it, you can use it for 25 years. Those solar panels are designed to last at least for 25 years. So that means if you get enough for your household, that means you don't need to pay NEPA bill or buy fuel for generation of power for 25 years. During those 25 years, the NEPA bill, the NEPA tariff will increase. The cost of fuel may increase. So, but because you have bought your own, there is no increment. You continue to enjoy it. So that is it for the lecture today. We continue again tomorrow. Read your notes, read it very well. Then get ready for a mini test. Thank you.